Hey guys, welcome. In this video, we are going to classify the MNIST dataset using NNTOOL Matlab. Let's get straight to it. Well, before starting, if you guys don't know about the NNTOOL, I highly recommend you to see my previous video where we talk about the basics of NNTOOL. Okay, let's start. First of all, we have to download the MNIST dataset. We are going to download it from Kaggle. I have put the link down in the description. So there are two CSV files, the MNIST test CSV and the training CSV. So you're gonna download the training CSV file. Just click in the download button. So you have to download it as a zip file, and when you unzip it, you are going to get a CSV file. If you open the CSV file, we can see there are about 60,000 data in the dataset, and the first column here is a representation of the labels. That means the 5 is the image of 5, and this row is all our input variables. So here we have all the pixel values, the 784 pixel values of the image of 5, and so this is how the data is stored. Okay, so now we have to import the data in Matlab. Well, in the previous video we just copied the data from the CSV file and put it in a variable, but in this case we cannot do that because our data set is very large. So what we have to do, we have to import data. Now we have to select the CSV file. This is gonna take a while because the file is very large. So once the data is loaded, we're gonna import the input data. To do that, we're gonna select this cell and we go to the last cell. Hold shift and click on the last cell. So now we have selected all the data, all our input data, but not our labels. Now we click import selection. Click yes. This is gonna take some time. Okay, here we have our variable. Let's rename it and we call it input. Now we have to import our targets same way. Click import. Okay, so this is the new variable. We call it our target. Let's check. So these are our inputs and these are our targets. Okay, so we can see the argumentation is not correct because our targets should be in a row, and the input, this row represents a single input, but we have to order it in each column. So we have to transpose it, but here we can see you cannot transpose it. Why we cannot do that? Because the data class is in table, so Matlab is not reading this as numerical values. These variables are in table, so we have to change the data type. So whenever Matlab reads data from a CSV file, it saves as a table. To change, we have to write some commands. Let's say input equal to okay, so this command will turn this variable data type table to array. So what are we doing here? We are calling a new variable, and the new variable will be whatever is inside this input variable and convert those table to array. So once we hit enter, here you see it's written table. So the MATLAB is actually converting all the values from table to array. Okay, done. Now you can see it's saying double. That means all the values are converted to numerical values. We're gonna do the same with our target. We're gonna say target is equal to hit enter, and we have our variables ready. So now we cannot transpose this. So we hit transpose, and our target also transpose. So here we can see the targets are in a single row and the inputs are organized in columns. That means this column, the whole column represents 5, and this column represents 0, and so on. And so we have 784 inputs for one output, and we have total 60,000 data points. Okay, now let's open NNToolbox. So first we're gonna import the input data and target data. Pick import, select input and import as input data. Select target and import as target data. Okay, so here you can see we have imported our data in input and target. Now we have to define our network. Click new. Here is the network name. Select the input and target variables. Training function, we're gonna stick with train GDX. Learn GDM. Performance function, mean square error. Number of layers 3. Okay, so this is from my previous networks I've used. Okay, so let's give total 50 neurons in layer 1 and 25 in layer 2. And select tan sigmoid function for every layer. Let's look at our network structure. So here we can see we have 784 inputs feeding to a 50 hidden layer 1, 50 neuron hidden layer 1, and then 25 neurons, and then we have our one single output. Okay, so now here we have our first network. Okay, so now we're gonna train this network. First selecting our input and targets, and we're gonna change the training parameters. Let's just do 250 for the first run. Validation fails to 250 as well, and let's put our minimum gradient to 10^6. Okay, let's train. Okay, let's look at the performance. See, here you can see decreasing mean squared error, which means our network is actually training the data very well. You see a regression. Okay, so the regression line is very good. So this proves that our network is actually improving. So we just have to train for a lot of iterations. Okay, let's do 5,000 iterations this time. I'm gonna put max fail to 5,000 because I don't want the validation fails to stop training the network. I want it to run for the full 5000 epochs. And let's also lower our minimum gradient. You can always stream. So I'm gonna skip this part. Okay, so our 5000 iterations is complete. Now let's check our performance. It's like the previous one. The mean square error is minimizing with every epoch. Let's look at our regression. Okay, so the regression graph is also quite good. So here we can see that the zeros are close to zeros. So this is here the x-axis, we have our targets, and the y-axis we have our outputs. That means this in the y-axis is actually predicted by the network, and the x-axis we have what the network should be able to predict. So the zeros are close to zeros, ones are close to ones, the nines are close to nines. Okay, so this looks good. So now let's look at our outputs, actually compare our outputs to the targets. So we can find the outputs here. So after the training, the output data will be saved here. So let's open. Okay, now let's compare this with our target. So here you can see the first 5 is 4.6, 0.040, and 2.644. So it's okay. 0.741 and 8.549. So you can see this the output is pretty close. So all we have to do is train this data more, like 20,000 iterations, and that will continue to get the outputs closer to the targets. And we can also try other network structures to test other, changing the neurons in the network can change the output also. So that can be a trial and error option for us. So that would be all for this video. I hope you enjoyed. Don't forget to like and subscribe. Thank you.